So hey, we're gonna continue with complex numbers today. Hopefully you guys did good on your test, and this is what you guys, so this is Wednesday's lesson. All right, so we're gonna start with multiplying conjugates. We're gonna remind you of what a conjugate is. We're gonna look at how to do division, which we're actually gonna use multiplication to divide complex numbers. And then the last one is we're going to solve quadratics that have imaginary solutions. Okay? All right. So first thing, so conjugates. So what's a conjugate? So now that you remember what conjugates are.
Like, isn't that like A plus BI or something?
Yes, so, well, that's a complex number, but if I give you 3 minus 2i, the conjugate of 3 minus 2i is, if you change the middle sign, it's 3 plus 2i. So these are conjugates, when the middle sign is different, okay? If I had -1 plus 4i, then the conjugate of -1 plus 4i would be -1 minus 4i. All right, so whatever the middle sign is, we change it, and those two are conjugates. So what I want to show you guys is what happens anytime we multiply conjugates. So if we take these first two, we'll call this example 1, and we multiply these, look and see what happens when we multiply conjugates. So go ahead and do that, and then we'll go through it, and then of course example 2. So go and do both of these and see what's interesting that happens, because when you multiply conjugates, something always happens. So what is interesting that happens when you multiply conjugates? No pressure, make sure that work is good. There, good. Okay. So what'd you get on the first answer?
13.
You got 13. And what'd you get for the second answer?
17.
17. All right, we're gonna go through it and see if that's right. So what might you say, because thinking about the last lesson when we did these, when we multiply, what is maybe interesting that happens that you might think of here?
You get an I squared.
You get only an I squared. What happens to your I terms?
They cancel.
So there's no I in this. Okay, so the I will cancel every time. So let's see. You did first, you get 9. So look at what happens to outer and inner. Outer is plus 6i, right? Inner is minus 6i. So what's going to happen to those two?
They cancel.
They cancel. And then when you multiply here, minus 4i squared, we know to change it. So 6i and minus 6i cancel. Minus 4i squared changes to a plus 4, because I squared is a negative, and that's where you get 9 plus 4, which is 13. Is it always going to happen for conjugates? So let's go one more time, see that it happens, and then we'll make a note on that. So if we do first, we got 1. Outer, you get what?
Plus 4i squared.
Well, just plus 4i, right, on outer.
Plus 4i.
Yeah. And inner, you get what?
Minus 4i.
Minus 4i. So again, those two are going to cancel, and then last we get minus
16i squared.
Minus 16i squared. So anytime that you have conjugates, you really can skip the outer and inner, because they're going to cancel. So what we're going to do, we're just going to make a shortcut now. Whoops, plus 16. So 1 and 16 is how you got 17. So if we have one more, so let's say this example 3 here, 5 minus 2i, 5 plus 2i. So first question is, are they conjugates? The answer to that is yes. What I can do is, I need only just do first and last, because if I multiply first and last, I know outer and inner are gonna cancel. So I can just save time. So if I multiply first, we get what?
25.
25. We do last, we get
Negative 4i squared.
negative 4i squared. I can skip outer and inner if I want, only for conjugates. Okay. And you get 29. Okay. So we can skip outer and inner in full method when multiplying conjugates. And then the other thing happens that you kind of talked about is that we lose the I. There's no I. So if we look at all these answers, there's no I. Okay. So what we're gonna have now is what if we're doing a division? How do we divide complex numbers? So first of all, is everybody good with? Are we good with multiplying conjugates? Okay. All right. So division. All right. So from last week we did adding, subtracting, multiplying complex numbers. Now we're going to look at dividing. So let's just say we have, we'll call this example 4, 5 over 3 plus I. Okay, and we're going to dividing, and we're going to divide and write the answer in standard form. What's the standard form of a complex number?
A plus b.
Yeah, A plus BI. I know we're running low on room, so. All right, so the way we're gonna divide, the reason I put multiplying beside division is this. We're gonna get rid of the I down here so that it can be in standard form. And the way to get rid of the I is if we multiply the top and bottom by the conjugate of the bottom. This is what we're gonna do. So anytime we're gonna divide, we're going to multiply top, or so I shouldn't really say top, what should I say? If it's the top of a fraction, numerator and denominator by the conjugate of the bottom. Okay. All right. So what would I multiply the top and bottom by?
3 minus I.
3 minus I. Okay. 3 minus I. So we'll do a 3 minus I here and a 3 minus I here. And then if we do that, we'll be able to write our answer something plus something I. Okay. So on the bottom, I'm going to have to use full method, but I can cheat. I'll just do this one, but just to show you again that outer and inner will cancel. You go ahead and take a second and do it. And I'm just going to make a note. I want to add this to for conjugate. So if A plus, just to make sure everybody's clear, if A plus BI is a complex number, then A minus BI is its conjugate, just to make sure everybody's clear on that. Okay. All right. So if you want to look at her work real quick, see how she's doing, and see what she gets, and then we'll see if we get the same answer. So you remember, you got to write your answer in standard form. Feel good about it?
I still have a fraction.
Still have a fraction. Okay, I'll show you how we'll get rid of that. But do you have the I in the numerator?
Yeah.
Okay. All right. So it looks like you got, what did you get in the top?
3 minus I.
All right, did you multiply by 5?
Yeah, but
Yeah.
the bottom's 10.
Very good. Okay. So let's look at what happens. So I guess if you do the bottom first, I'll just go through full just to show again that outer and inner will cancel. 9 minus 3i plus 3i minus I squared. All right. So again, outer and inner cancel only when we multiply conjugates. And then the top is 15, right? If we do 5 times both of these, minus 5i. So technically, these are in parentheses here when I'm multiplying. Okay, so those cancel. Negative I squared is plus 1. Are you okay if I go one more spot right here? Good, we'll make it.
Probably.
Yeah, I'll drop that right here. So 15 minus 5i over 10, and then you could, so what you can do is this. So when you get to this point, here's an easy way to reduce and put it in a plus bi form, because it's got to be something plus something I, or something minus something. What you can do when you get here is just split it into two fractions. Treat the 10 as a common denominator, and then you can reduce each one and get your answer. So here I can take a 5 out of both, so that'll reduce to 3/2, and here that'll reduce to 1/2, and that's your answer. Now it's of the form a plus bi. In this case, it's a minus. Same thing, standard form. Okay. All right, let's do another one. We're okay over here. So we'll call this one example 5. 2 plus I over negative 4 minus 3i. So now we have a 2 plus I on top. We're going to divide. So again, the question is, can we divide and write the answer in standard form? All right, so setting it up, and then I'm going to let you guys work. So what do we multiply top and bottom by, Natalie, and then we'll let you finish the problem.
Negative 4 minus 3i.
Or
plus 3i.
Yeah, so we got to make it the conjugate. So we change the middle sign. That's what makes it the conjugate. And that's going to force what to happen to I on the bottom? What's going to happen to I?
Go away.
Yeah, go away. It'll cancel. Okay? So that red is the conjugate. All right, so you guys take a second and work that, and then we'll do our work right here. All right, I'm gonna go ahead and erase this. They can always rewind it, right? So. The red doesn't show up very well. So I'll write it again. Okay, finished?
Yeah.
I don't know if everybody else will work that fast, so you can always pause it if you're not done. So, all right. So, where did you work first, the top or the bottom?
The top.
Okay, the top. So the top, do I have any shortcut, or do I have to just do full method?
You have to do FOIL.
Yeah, we have to do full method because they're not conjugate. So just tell me each spot and we'll write it out. What did you get?
Negative 8 plus 6i minus 4i plus 3i squared.
Very good. And then did you just go ahead and clean it up, or did you just go to the bottom?
I went to the bottom.
Okay, good. So now on the bottom, since these are conjugates, I can cheat a little bit. We get what?
16.
And then do I need to do outer and inner?
No.
No, because they're gonna cancel. So if we do last, we know outer and inner are gonna cancel. When you did last, you got what?
Negative 9i squared.
Negative 9i squared. Just leaving that hole there because outer and inner would have been what? 12i and negative 12i, okay? So that changes to a plus 9, which that number at the bottom would be what? 25, okay? So what did you get on the top now? The 3i squared we're gonna make into a
Negative 3.
-3. So what's your numerator?
7. 11 plus 2i.
So this is good, but technically it's not standard form. So what did I show we have to do to get something plus something I?
Split the fractions.
Very, very good. So you make it negative 11/25 and 2/25 I, and there you go. You've written your answer in standard form. All right. So are we good with multiplying conjugates? Now, sometimes don't overthink it. Sometimes you might get something like this. We'll show one more, and then we'll go on to solving quadratics. So example 6, still dividing, but they may just put one piece in the bottom. So say you have 3/5i. Okay, there's no other, it's not 1 minus 5i, it's just a 5i. So technically, it's like saying 0 plus 5i. So we're still going to multiply by the conjugate. So what would the conjugate of 5i be?
Negative 5i.
Negative 5i. And that will allow us to get rid of the I in the denominator. Okay. So if they just give you a 5i, you just multiply top and bottom by negative 5i. This becomes a pretty easy problem. The top is what?
Negative 15i.
And the bottom is
Negative 25i squared.
I squared, but that's going to turn into a
25.
plus 25. So we got negative 15i over 25, which is standard form. However, do we like to answer 15/25? No. What can we do?
Divide by 5.
Yeah, take out a 5. So this will leave a 3, and that'll leave a 5. You should get negative 3/5 I, and that's it. So basically, dividing is just a way to rewrite into standard form. Okay. All right, the last two that we're going to do. So we come back over here to our goals. We know what a conjugate is now. We know how to multiply. Division, okay? And just to make sure, I'm going to put it right here. So if a plus bi is a complex number, that's not a hashtag, it's a number. Then what is its conjugate?
A minus b.
A minus bi is its conjugate. All right, just to be clear on what conjugate is. All right, we got that. We've got multiplication. And you guys know how to solve quadratics, but now, since of our work with complex numbers, we may get imaginary solutions. So we're going to put this here, one where you don't need a formula. So here you've got x squared plus 25 is 0. So take me through how we would solve this, and then how we deal with the imaginary number. So what's the best way to solve this quadratic, Natalie, if it's x squared plus 25? What should we do?
Subtract 25.
All right, so once we subtract 25, we pick up a negative, and then to solve, we want to do what to both sides?
Square root.
Square root of both sides. And anytime I do a square root to solve an equation, what should I put in front of the square root?
Plus or minus.
Plus or minus. Now, all right, so almost done. X equals. What do I do with a minus under a square root? I move it out as an
I.
I. So plus or minus I square root of 25. And what is the square root of 25? 5. So do I say I5, or what do we say? 5i. Okay, there's that one. All right, so you may get some simple like that, which I know you guys are good with. This last part with the quadratics, I'm not worried about. So I think you guys will be fine with that. And then we'll do one more that I believe has imaginary solutions. So let's do x squared plus 2x plus 5, okay, equal to 0. This should be imaginary. So how are you going to solve this quadratic? Well, now that we have two x's, what should we do?
The quadratic formula.
Quadratic formula. So we should use quadratic formula, and there's a chance that we may pick up imaginary solutions. Quadratic formula is, we got that in our head, it's no worries. All right. So do you want to tell me what to write on this one? What goes in where? So it's going to be negative.
Negative 2 plus or minus square root of 2, negative 2 squared.
Or just positive
Yeah, just 2 squared.
2 squared.
Minus 4 times 1
over 2. All right, so let's see what happens. So we get negative 2 plus or minus the square root, that's 4 minus 20 all over 2. And 4 minus 20 is?
Negative 16.
So negative 2 plus or minus the square root of negative 16 over 2. And I'm hoping by now we know what square root of negative 16 is. I think everybody does. We know that the square root of negative 16 is what?
4i.
4i. Okay? 4i over 2. Now, this is similar to what the kind of answer you got with your conjugates. Remember, we didn't leave it all over 2. We did what with this so that we could get it a plus bi?
Split it.
Split it. So we're going to make it negative 2 over 2 plus or minus 4i over 2. So our final answer would be what?
Negative 1 plus or minus 2i.
Okay. Very good. If you want to just get that picture there. And that is those are your what? Solutions. We can't call them x-intercepts now because they are imaginary. All right? And that is Wednesday's lesson. So you've got, I'm going to give the assignment, so let's look over here. So it's still in section 2.4. Whether you're, whichever class you're in, you have access to these problems. You're going to do 51 through 57 odd. Oh, no, I'm sorry. I always do this, don't I? 43 through 57 odd. And then 63 through 83 odd. And I'm going to give you 85 and 87. In these two, it has an I cubed. I want you guys to figure out what I cubed reduces to. So I'm not going to teach. You got to figure that out in class. So there's an I cubed in these two problems. I cubed reduces to what? You figure it out. If not, okay. You just have to wait till the next week. That's the lesson. All right, thank you.